Good morning, Valley Middle School STEM. Welcome to the first rotation of STEMSday activities in the On the Moon series. Today's activity is called Moon Rover. We'd like to thank the Society of American Military Engineers for sponsoring today's event. Let's take a look at your task. Today, you'll be asked to design and build an LVR, or a lunar roving vehicle, in your small groups. Now, the lunar roving vehicles, or lunar rover, or moon buggies as they were called, were used for the Apollo 15, 16, and 17 missions on the moon between the years 1971 and 1972. Today, your task will be to design and build a rubber band-powered vehicle that can travel at least 2 feet. Now, you may not see the connection, but there are a few similarities between NASA's challenge and yours. 3 of them specifically. Both were tasked to build a light or compact vehicle that could travel short distances at relatively low speeds. The differences, however, were monumental. NASA's challenge, they had to build a vehicle that would travel over rough terrain in a low-gravity vacuum. Yours is traveling over carpet or tile. NASA had to create a battery-powered vehicle. Yours is powered by a rubber band. They had 17 months to complete this task. You have 25 minutes. NASA's had to travel 20 miles on the moon, or approximately 4 hours of run time. Yours, about 2 feet in 4 seconds. NASA's price tag, however, was $38 million, and that was in the 70s. Yours is $1. All right, $38 million. I'm not sure Mr. Bettini would find that economical. He would probably suggest they used a bicycle or possibly walked. I think I agree. Take a look at the materials we'll be working with today. You'll have a ruler, some straws, rubber bands, a pencil, 2 lifesavers, masking tape, a scissors. You're also going to have a box blank. You can take and fold that box into the shape here shown, or you can cut it up, use it however you want. We do not need it back. It's yours for your activity this morning. You'll be working under some constraints and parameters. First of all, your rover needs to be self-powered. Groups may only use the materials provided. The rover must travel 2 feet on a flat surface. It cannot be on an incline. You may not use any electronic devices for research or other purposes. Once again, the greatest constraint this morning will be time. You'll have about 25 minutes. You're going to have to work fast. Now, speaking of fast, just how fast was the lunar rover? Well, what do you think? Faster than a garden tractor or slower than a garden tractor? Actually, about the same speed. 8 miles per hour was the run speed on the lunar rover. Now, one crazy astronaut got it up to 11.2 miles per hour. That's about as fast as a golf cart. That's the moon speed record, 11.2 miles per hour. All right, here's how the morning will lay out. You'll be in that imagine, design, test, and evaluate stage for about 25 minutes from 7:50 to 8:15. Then we'll have cleanup time. Wrap-up conversation at 8:20. Homeroom will end this morning at 8:25. As you work through the process, we'd like to be reflecting upon these questions. What do you have to do to make that rover move? What are the different ways you can use the rubber bands to power the rover? Will the shape of the wheels make a difference? Early finishers. How is friction impacting your rover's performance? Is there a way to reduce that friction? Try testing your design on different surfaces. Do the results vary? Cleanup is pretty straightforward, folks. Please put the tape, the scissors, the pencil, and rulers in the bin. Throw everything else away. We don't need it back. We appreciate it. Thanks. Hope you enjoyed the STEMSday. And just one final thing. How could we talk about travel on the moon without looking at the most famous moonwalker of all times, Michael Jackson, 1958 to 2009. He was amazing. Have a great day.